Hello everyone, we'll go to the next problem which has a point load and UDL. This is the problem. Okay, this UDL is 10 kilonewton per meter, point load 25 and 10 kilonewton. First find out what is a reaction. So for that summation Fi equal to 0, consider upward as positive. So Ra plus Re minus 20 minus 5 minus 10 and minus 10 into total distance is 4. For UDL you have to, it will be in kilonewton per meter. So you have to convert into kilonewton. So for that force into a perpendicular distance. So 10 is your force and total distance of UDL is 4. So it will be 10 into 4 equal to 0. Then Ra plus Re equal to 75 kilonewton. Then take moment at A is equal to 0. Consider clockwise as positive. So this is clockwise 20 into 2 plus 5 into distance 4 plus 10 into 5 plus this UDL. First convert it into kilonewton, that is 10 into 4, and for UDL the perpendicular distance or centroid will be half of the distance, that is total is 4 by 2. Okay, this is always you have to consider while taking the moment, you have to consider the distance as half of the distance. Okay, 10 into 4 into 4 by 2 minus Re into total distance is 6 meter equal to 0. Calculate and get the value of reaction, that is Re, and substitute in this equation you will get Ra. Then write here what is Ra. Ra is 43.33 kilonewton. Re is 31.67 kilonewton. Okay. Next we'll calculate shear force. Okay, I'll consider from left side shear force calculation. So for left to right, what is the sign convention? Consider upward as positive and downward as negative. Okay, you are considering from left to right. Okay, we'll see the point A, shear force at left of A, split it and do, because you have UDL in the problem. So left of A means your section is here, so it will be no other forces, so it is 0. Then shear force at right of A, so your section will be here, right of A, you have this reaction value upward, so upward according to a sign convention is plus 43.33 kilonewton. Next will come point B, shear force at left of B, that is left of B is here. So you will have here 43.33 kilonewton and half of the UDL, or up to 2 meter UDL you have to consider. So this is plus 43.33 and UDL is minus only up to point B, that is only 2 meter you have to consider, that is 10 into 2. Okay, so what is the value? 23.33 kilonewton. Next, shear force at right of B, that is, suppose your section is here, right of B, you have to consider this force. Just directly take the previous value, that is 23.33, and then you just subtract or add the value according to the sign convention. So this is minus 23.33 33 kilonewton. Okay, next shear force at left of C, that is this. Again you have to consider half of the UDL is considered, so consider this part UDL, that is plus 3.33 minus 10 into again 2. What is your value? Minus 16.67 kilonewton. Next shear force at right of C. So the final value is minus 16.67. Right of C you have to consider this 5 kilonewton, that is again minus 5. The answer is minus 21.67 kilonewton. Now you combine this CD, you can do that, or just you consider the same way, left of D and right of D. So left of D, there is no other force, it will be the same value. Shear force at right of D, so minus 21.67 and minus 10, so it will be minus 31.67 kilonewton. Last point, shear force at left of E. Again no other forces, so it is same, minus 31.67 kilonewton. Last shear force at right of E, that is minus 31.67. Again this will be upward, so plus 31.67, which is equal to 0. This will be your check. So if you are considering from right to left also, while case of right to left, upward will be negative. So you will get this value minus 31 point. Left of right of E will be 0, left of E will be minus 31.67. So you can do that from the both the side and check for your purpose. This is shear force calculation. Next will come with the bending moment. You know that bending moment at free end will be always 0. Only in such case where there is any moment acting on that point, then you have to consider the bending moment. Otherwise, at the free end it will be always 0. That is bending moment at A and E equal to 0. Okay. Next we'll see bending moment at point B. Point B, so you'll have this 43 point force into distance moment. So 43.33 up to point B, that is 2 meter, and for this case also upward positive, downward negative, that when you come on any side, from this side or that side, this bending moment value upward always positive, downward always negative. So plus 43.33 into 2, then you have to consider up to this point UDL, that is minus 10 into 2, that is your force, and distance will be 2 by 2. Okay, 2 by 2. Remember, half of the distance. So what is the value? 66.66 kilonewton meter. Unit is kilonewton meter. It will come with the point D, point C, bending moment at point C. This is your point. So you have to consider. You can do from this side or that side. We'll check from both these sides. So first 43.33 into what is your total distance? 4. Okay. Less. Then minus 20 into this distance is 2, and you'll have minus UDL value 10 into, here you have to consider up to C, so total full distance, that is 4. 4 into 4 by 2. Just calculate what is the value. Let's see, 53.34. You can calculate from this side and check. That will be, for example, if R, bending moment at C, you're coming from this side, plus 31.67 into up to C, that is 2 meter, then minus 10 into 1. Just check, you have the same value, 53.34 kilonewton meter. Is it clear? Next we'll come with point D. Bending moment at D. This is a point, you can consider from this, there is no much force. So plus 31.67 into 1. So it will be 31.67 kilonewton meter. This is about bending moment calculation and shear force calculation. Now just mark the shear force diagram. Like that. You know that all the positive values you have to mark up below, above the line, and negative values below the line. So suppose this is your shear force diagram line. Mark the points A, B, C, D, and consider as per the calculation. First left of A was 0. Then what is the right of A value? Right of A is 43.33. Somewhere here. Okay. Next, left of B is 23.33. So 23.33. Again, right of B 3.33. Next, we'll come to point C. Left of C is minus 16.67. So below the line, minus 16.67. Again, right of C is minus 21.67. Left of D is same, minus 21.67. Right of D is 31.67 minus 31.67. This will be minus, left of E is minus 31.67. Then it is 0. The line. For UDL, it will be a slope line. Just mark Next will be 16.67 like this. So this is your positive region, this is your negative region. This is SFD diagram. And remember, wherever there is a change in sign, that is where shear force is 0. In this point you have shear force value as 0. Okay. So at that point you will have maximum bending moment. That calculation you have to do. Okay. So just mark this as X. Okay. So to calculate maximum bending moment, okay, we'll have here similar triangle. Consider this similar triangle. This region and this region. Okay. What according to that similar triangle, you can just divide the equal distance. So here which are the known distance? This you know, that is 3.33 divided by this distance is 3x, that is 3.33 by x, which is equal to, now this is your region. What is this distance? Total is 2, so it will be 2 minus x. What is this value? 16.67 divided by 2 minus x. Solve and get the value of x. X value will be 0.33 meter. Okay. So I'll explain again. To find out maximum bending moment, just see where is the shear force is 0. There you will have maximum bending moment, and consider for up to that mark point as x distance, and taking the similar triangle, just solve the similar triangle and get the value of x. So for that case, suppose this is your triangle, consider 3.33 by this distance is x, which is equal to, this is 16.67, this distance is, total is 2, so it will be 2 minus x. Solve and get the value of x, that is 0.33 meter. Now at this point you have to find out the maximum bending moment. Okay. So for that case, just mark this point in your problem and mark it as F and find out bending moment at F. So bending moment at F. First, this, what is this distance? Plus 43.33 into your distance is up to this point, that is F. That will be 2 plus 0.33, that is 2.33. Then consider UDL up to that point, that is minus 10 into, directly consider total UDL, that is 2.33, and distance will be 2.33 by 2. Next again you have this 20 kilonewton, that is minus 20 into 2. This will be only just 0.33. 0.33. Calculate and get the value of maximum bending moment. Maximum bending moment is 67.21. 0.21 kilonewton meter. Okay. Now mark all the points. So this will be a BMD diagram. At A and E is 0. Okay. At point B is, bending moment at B is 66.66. 66.66 kilonewton meter. At point C is 53.34. Point D is 31.67. And you have this point, that is at point F, maximum bending moment 67.21. So this line, above this line, 67.21. Okay. For UDL, you have second degree curve. So you have to draw as a curve. This is your curve, and again this is your curve up to UDL, up to point C, second degree curve. Okay. Then for point load, it will be a straight line. Just mark. All the values are positive. So we have, this is your region. This is your bending moment diagram. Okay. Okay, thank you.